Hello, this is question 2 on your June 2019 mechanics paper from Edexcel, and you have a particle that moves with constant acceleration, so the acceleration is constant, which means we can use Zubat equations just written as vectors, so 2 minus 3. Time t0, particle is at point A and is moving with this velocity, so when t is 0, the velocity is going to be the initial velocity, so I'm going to call it u, is minus 1, 4. And at time t seconds, p is moving in the direction of this vector here, which means it's parallel to this vector, yeah, the velocity. Find the value of t. So if the velocity is parallel to this vector, what we are going to write is the vector velocity. I know the acceleration is constant, so I can use the Zubat equation written as vectors, and I know the initial velocity. So the final velocity after t seconds is going to be the initial velocity plus the acceleration times the t. Final velocity is what I need because it's the one that is going to be parallel to this vector. Initial velocity is minus 1, 4. Acceleration is 2 minus 3. And t is what they call capital letter T. So this velocity is minus 1 plus 2t, just adding the vectors, and 4 minus 3t. This vector is parallel to this one, which means the quotient between I component and j component is going to be equal in both of them. So minus 1 plus 2t divided by 4 minus 3t is going to be equal to 3 divided by minus 4. Yeah, this comes, just in case you don't remember, when the vectors are parallel, one is the other multiplied by a constant, so we can write that 4 minus 3t. This vector, if it's parallel to this vector, is going to be a constant multiplied by that one. So a constant multiplied by 3 minus 4, which means first component is going to be equal, 3 lambda, second component is going to be equal. And when I divide to eliminate lambda, this equation by this equation, I have this component divided by this component equal, the lambda are cancelled, 3 divided by minus 4. Yeah. So it's up to you if you do the whole thing or you just straight away write this. If I multiply, I have minus 4 times minus 1 plus 2t is going to be equal to 3 times 4 minus 3t. If I expand the brackets, I have 4 minus 8t is going to be 12 minus 9t. So I have 90 minus 80t in this side and 12 minus 4, 8. So time is 8 seconds. And this is part A. Then for B, it says at times t 4 seconds, P is at another point. Find the distance AB. So the displacement is going to be, again, using Zubat equations written as vectors, displacement is going to be u t plus 1/2 a t squared. We have to check, or it's better to call this r, because that's how we call it when it's vectors. It's the position vector, really. So I'm going to check if the position vector is different than 0, the initial position vector, just in case. So the initial position vector is when t is 0, and when t is 0, this is 0. So my position vector, initial position vector is 0, 0. And they don't say anything else, yeah? Sometimes they say the initial position vector is this one. If this is different than 0, 0, I will have to add it here. Yeah, well, add it here. Add it here. So this is what is giving me the position vector when the particle is at B. Yeah. So the position vector is the initial velocity that we said it was minus 1, 4. Time is 4. Plus 1/2, acceleration is constant, 2 minus 3 times 4 squared. So this is minus 4, just multiplying the vectors, 16. This is 16 divided by 2 is 8, so 8 times 2, 16. This is plus. And minus 3 times 8, minus 24. So this vector here is 12 minus 8. No? So this is the position vector of B. And the position vector of A is this one, yeah? Because when t is 0, the particle is at A. They say at the beginning, yeah? When t is 0, particle is at B, at A. So we know RA and RB, which means vector AB is going to be RB minus RA. RB is 12 minus 8, minus RA is 0, 0. So my vector AB is 12 minus 8. So the distance is going to be the magnitude, the length of this vector, which is 12 squared plus minus 8 squared. And they say the exact distance? No, it just says the distance. So if you do this with a calculator, you have 4 root 13. If you want to evaluate and give a number, we have 14.42 meters. And this is to 2 decimal places. Yeah, either way, this one or this one, it doesn't matter. Yeah, and that's all with this question.